Good morning, everyone, and welcome to our webinar. My name is Peter Corliss, and I'll be your host for today. Before we get started, I'd like to review a couple of quick housekeeping items. We welcome your questions. Please use the Q&A button located at the bottom of your screen to ask your questions. Remember, you can enter them at any time during the webinar. You don't have to wait till the end. We will answer as many questions as we can get to at the end of the presentation. Also, please note that today's webinar is being recorded. We will email you a link to the recording and the slides following the event. Before we begin, we're also going to push you a quick poll question. Where are you in your NoSQL adoption? I currently use ScyllaDB. I currently use another NoSQL database. I currently use Apache Cassandra. I use another NoSQL database. Maybe you're just evaluating NoSQL. Maybe you're interested in learning more about ScyllaDB, or none of the above. Wherever you are on your NoSQL journey, we'd love to hear about your experiences. All right, thanks for those responses, and let's get started with recording. All right, welcome everyone. My name is Peter Corliss, the Director of Technical Advocacy at ScyllaDB. I'll be your host for today's webinar on ShareChat's path to high-performance NoSQL with ScyllaDB. We are pleased and honored to host Geetish Nayak, staff engineer and architect at ShareChat. Before we begin, before we bring Geetish to the stage, let me tell you a little bit about ScyllaDB and why it is the database for game changers. It was the InfoWorld Technology of the Year. It solves a heck of a lot of problems with other legacy NoSQL databases with higher throughput, lower latency, and best of all, a lower TCO. You can see us written about in InfoWorld and Forbes. There's plenty of articles about the database built for game changers. But I think what's more important, let's go on to the next slide here, is the fact that there's so many companies who are changing their industries by using a big, fast, monstrous database like ScyllaDB. You can just see just a couple of the logos here. Now, we have plenty of these use cases on our website, and you can read about those after the event. But now, today, we're going to bring you a new story, which is about ShareChat's use of ScyllaDB. And with that, without any further ado, I'm going to hand this over to Geetish and just take it away, and let's hear about your story.
Thanks a lot, Peter. And myself, Geetish, I'm a staff engineer, architect in the platform team. Overall, I have around 10 years of experience working in the IT industry, working at MNCs and also startups. Like I did my education in information systems from Carnegie in Pittsburgh, and I've worked at Intuit and LucidWorks before joining ShareChat. So let me introduce about the company ShareChat. So ShareChat has two big flagship products, ShareChat and Mod. So ShareChat is basically a content generation platform where you can post videos, you can post some content like cricket, for example, or sports, or anything for that matter, any local content too. So we have around like 180 million users on a monthly basis, and around 46K shares happen of on this platform, and we spend on an average a user spends around 31 minutes on the ShareChat platform itself. And second big platform is basically Moj. Moj is a pure video platform where users or creators upload videos, and a lot of different users have a look at it. So these are very short form of videos, and we have around 160 million users on a monthly basis, and on average 34 minutes of time gets spent by a particular user. So as you can see, both of these apps are run at a very high scale on a daily basis. Like we get around 100 million to 120 million users on both of these platforms. So yeah. Okay, so as I mentioned, like because the scale is too high, we thought why the question. That's a fair question to ask. Like, why did we go for a newer database? So the thing is, basically we were using some existing databases, but as the scale uh, was tremendously growing, and we thought that we need a lot more granular metrics while debugging, so that we can get the most out of the databases that we were using. Also, the thing is, we wanted better performance, lower latency, higher throughput, so that our apps can perform better. Since it's a social media app, the content needs to be loaded, or the data needs to be loaded at a pretty fast pace. So we definitely wanted like single digit millisecond latencies. Second thing is basically DR as a first class citizen, so that our services are much more highly available when there are disaster kind of scenarios. And the fourth most important thing is control. Even though we wanted to be managed, but we wanted to control some of the basics basic things, like example, compaction strategy, changing the compaction strategy on the fly for a given use case, changing the consistency levels, replication factor, how much data do we want to cache on the database, and things like that. So basically, like, overall we wanted to have a far more control over our databases. And the last, again, like, most important thing is it needed to be cost effective. As ShareChat was growing, our costs were also growing at the similar pace. So we wanted the database to be very cost effective, and that's the reason why we were looking for a newer database. Okay, so why we chose ScyllaDB? So let me give you some background. So my manager actually posted a very on a Slack conversation, posted a white paper on a share channel about ScyllaDB. So like I just took a glance at it, I found the paper really interesting. Then I went and did a lot more research of why ScyllaDB is faster, the C star framework, shard per core architecture. It looked like pretty exciting. So while researching, I saw that there were comparisons being made by ScyllaDB with some other databases, some of the databases we were using, some of the databases that are well known in the industry, and the numbers looked like pretty good, like far more better to be true. So like I and my colleague of mine, like Abhirup, so we thought, what, why don't we put this to test on one of our production uh, workloads? So since ScyllaDB had provided Kubernetes operators, and we heavily use the Kubernetes platform, so we just thought of, what, why don't we spin up a big cluster that we can think of, and and try it against one of our production workloads. So the Slack, also there's a Slack channel of ScyllaDB which helped us set up those things, and we ran the production workload, and we saw that the performance was very good in terms of the number of nodes that were required to support that use case, and also like the kind of latency numbers that we were getting. So it gave us enough confidence that the white paper, or the whatever articles were there on the internet about ScyllaDB were not something made up. So these were actually true numbers. Then again, like, we ran other few workloads which had global secondary indexes and things like that, and we got similar results. So then we went full throttle. You know what? Let's go full throttle on it, and let's adopt it. Then I and basically other folks convinced the management, and that is how ScyllaDB got onboarded onto ShareChat. Yeah. ScyllaDB gets used at at very good scale at ShareChat, and very different use cases. So our chat application, so which is similar, like how you would have seen WhatsApp or Discord. So we have chat applications which run totally on ScyllaDB. Our real-time notification framework again runs on ScyllaDB. So the third most counters again runs at a very high scale, and basically, since we generate a lot of posts and videos, we get a lot of likes, shares, comments. So all these counters get stored against a post in ScyllaDB, and this is one of the production workloads that we tested against when we were evaluating ScyllaDB. Ads data management platform. So given ScyllaDB is also so very good in terms of performance, like the latency numbers we get in some of the clusters are in microseconds. So some of the in-memory database workloads also use ScyllaDB, given that it's just very fast. And also, like, data science team is a heavy consumer of ScyllaDB, and their feature store is built on top of it again, which is at a very high scale. Um, So let's look at some of the architectures where ScyllaDB gets used. So as I mentioned, like counters that I was talking about in the last slide. So what happens is we have our own in-house Apache Kafka hosted internally, and all these views, likes, consider, like, 50 million people coming on a daily basis, and so much amount of content that gets generated, like, just alone in ShareChat. So all of the views for a particular posts, like, likes, shares, they all get pushed to this Kafka cluster, and we use basically Kafka streams. So Kafka streams, where we aggregate them, like, we have different priorities and things like that. So where we aggregate them, and after the aggregation is done, there's a write that happens to Scylla. Basically, we are using atomic counters, which is a feature in which is a data type in Scylla, and that is how it gets used. Again, this is at a very, very high scale. Second thing is data science feature store. So data science, like, has a feature store which earlier used a database, use the in-memory cache, use the application cache, because, like, it had very low latency requirements. And after that, like, after adopting ScyllaDB, they don't use any of these in-memory cache. There is no distributed cache, just single database ScyllaDB, which is handling all the read and write requests. And again, this is a pretty interesting use case. uh, Third thing is, as I told about the real-time communication framework. So like, basically clients connect to our front-end gateway nodes. So we have a bunch of gateway nodes, so which client is connected to which node, so that they can the backend services can send appropriate notifications, messages to that user. So all these data of which user is in what node gets stored in ScyllaDB, because we want very low latency when we are looking up, so that, like, so the messages get delivered pretty fast. So we use ScyllaDB in this case also, and again, this is a pretty interesting use case. Yeah. So overall, if I talk about, like, we talked about various different use cases. Overall, we are using around 70 to 80 terabytes of data is already in ScyllaDB. We plan to onboard additional 50 terabytes in the next 3 to 4 months. Like, given, like, we got a good amount of benefits already, and almost like 30 to 40 services are using ScyllaDB at scale. Our biggest cluster size is of 20 terabytes, unreplicated. So with replication of 3, it is like around 65 terabytes, and max throughput on every cluster, on a maximum, the max cluster is around 1.2 million ops per second. And the latency numbers are like in a single digit milliseconds. uh, yeah. So just to show the counters cluster that I was talking about, like, if you see, like, these are, like, this runs on like 6 nodes of n to Hyman 16. And if you see, the latencies are like in microseconds, even though the requests are in like good 170, where we go till max till 300K during night or peak hours. And it just works pretty much fine. We are actually planning to lower the number of nodes from 6 to 3, just because the load is like 27%. We can go beyond 70 to 75, 80%. So we are actually planning to lower the number of nodes in this cluster. Second thing is a notifications cluster. If you see, like, we go to million ops per second during peak time. Overall, it has, if you see, around 200 k ops reads and writes. And again, like, this is again at a pretty high scale. The peaks go to million 1 million, 1.2 million ops per second. uh, so yeah. So let's not now talk about, like, how has ScyllaDB helped ShareChat. So as I mentioned, like, for us, metrics was really important, because we wanted to know what is happening in our database. We wanted to know like where the bottlenecks are. I totally can understand that uh, no database is like foolproof. But the thing is, we wanted to have more visibility. The thing is, like ScyllaDB provides us that, like, you can go to like a vCPU and see what is happening in that vCPU, which was like really amazing to know, for us to know, like, are we making the right queries? Like, it has certainly improved our, like, our capabilities of debugging issues. Suggestion for best practices. So ScyllaDB has a very good, the dashboards has a very good feature where they tell, like, it suggests basically, are we making use of the right queries? Like, for example, like, if you're having range queries, you should directly bypass the cache and make a call to the disk directly, because, like, it does not make sense to read range data from the cache. Like, some other things like prepared statements. Are we using prepared statements in our queries? Are we using token awareness? All those kind of things. The dashboard already provides and flags you if you're not using these things. So you as a developer are inherently made sure that you use these best practices, so as to get the best out of the database. Like, it has helped us analyze our query patterns and things like that. Second most important thing is cost. Like, for some of our use cases, most of our use cases, I would not say some, most of our use cases, 95% of our use cases, we already see like a good amount of reduction in our costs, like from 50% to 80%. The counters use case that I was talking about gave us like 80% cost reduction, and we know that we can further go more because we can just reduce like 3 nodes more. So, and this is like across almost all the use cases that we are using. Performance and latency throughputs, as I mentioned, like, the latency numbers are in microseconds, and like we are able to go to million ops per second on some of the clusters. The thing is, because these latency numbers are so low, our application, no, the number of nodes on the application and also has reduced, like, because we are able to serve much more requests. Also, like, ScyllaDB, the good part is, like, uh, you can push the database to go beyond 80%, 85% of the CPU, and it still works fine. And we have seen that in real life. I can show you an example also, that we push the database to go like 80%, 85%, and it still works really nicely. Other thing is, like, tech guidance. I think we work very closely with ScyllaDB engineers, and they have given like a good amount of guidance, like what are the best practices that should be used. Like, any questions that we have, we directly ask them over Slack. They're just a message away, and they give us good guidance over Slack, or a document explaining things. So I think all of these has definitely helped ShareChat to a very good extent. So, as I was talking about the metrics part, if you see, like, if you see, like, we are already going, like, if you see, like, our database is already going to 100, like, no, not 100%, but at least more than 60-70% of the CPU. If you see the metrics, like, we get foreground reads per instance, and if like, you can further go like deeper into what is happening in a vCPU, and these kind of insights are really helpful for us right now. Like, give like getting like node and of core level metrics is something that we were really missing. Like, stability, in terms of stability, as I was talking, this is a very interesting slide. Like, we were doing some migration, and we, like, bombarded the cluster like a lot. And the thing is, like, we saw that, like, it does the CPU of almost every node went till 100%. But the good part is, this was during migration activity, and, like, the good part is, it was still serving requests, although with a degraded performance, but not a single node actually went down. Like, we rarely encounter nodes going down in all of the uh, clusters that we have onboarded. So it just goes on to say that the database is really stable, and we can confidently push the CPU beyond 80%, 85%. Very confident on respect to that, with very little effect on performance. So it's really stable that way. Okay, so we some of the best practices that ShareChat adopted. So basically, we learned actually from the mistakes that we did earlier with the existing databases that we were using. We adopted some best practices around, we are not going to share clusters across services. Every service has its own query patterns, traffic patterns, and things like that. So what was happening was, earlier, we had different use cases on the same cluster. Everyone was stepping on each other's foot, and one service uh, used to affect all the rest of the services on that same cluster. One bad service, so we wanted to make sure that all our Scylla clusters are independent. Like, every service gets their own Scylla cluster, and all the compaction strategy, everything gets tuned as per their requirements. So that has really helped us. So we have built a Scylla onboarding document. um, yeah. So if you if you scroll down a bit, so what happens is, every service writes their throughput, like how much is going to be the throughput, what are going to be their SLAs. If you see, there's a very detailed queries. So we tell every service that is onboarding to Scylla, what you have to write your queries first, because for databases like Scylla or Cassandra or any other NoSQL databases, it is really important that we understand what are going to be our query patterns. So if you see, every service goes through a detailed discussion of what the query patterns are going to look like, and then once these queries are returned, then we write the data we come up with the data model. There's a team of reviewers within ShareChat who have kind of a good amount of experience with ScyllaDB and another databases. So we ask the relevant questions, make sure that the data model is really performant, and there are no surprises once the production load hits. So this is one of the so we have made sure that we are not going to abuse databases. Otherwise, it bites us really bad down the lane. So this is one of the document, and every service without fail goes through it if they want to onboard to Scylla. Then the last final is a single database driver to talk to all of our databases, ScyllaDB being one of them. So we use different NoSQL databases, and we wanted to have a single driver to talk to all of these databases, so that people consider it these databases to be like NoSQL database, and they should not be very much aware of the best practices in each of these databases. So what the driver does is, you adopt the driver, all the best practices are already built in. For example, prepared statements, token awareness, all those kind of things are already pre-built, so you don't have to worry that much about it. So now what has happened is, because everyone uses this driver, we don't get these kind of non-prepared statements, queries and things like that, because the driver takes care of all of these things internally. uh, let's go to the next slide. So yeah, let's discuss how we plan to migrate data to ScyllaDB without any downtime from our existing databases that we were using. So as I mentioned, we created a centralized driver which is written in Golang, and that gets integrated with the services. So this driver is powered by a config store, which has which table is in which database. If you want to migrate to which table in ScyllaDB do you want to migrate, and the data types from database A. When you're migrating to ScyllaDB, what would be the data types? All those things are there in the config. So this driver serves as a kind of a middleware to do dual writes you can read from one database, all those kind of things it can do. And given in ShareChat we use like three different languages like Golang, Node.js, and Java, and this driver is like fairly complicated. So we thought, like, how do we duplicate all the effort that we have done in Golang to different languages? So that is where when we came up with the concept of the using shared libraries. So what we did was, we all our business logic is gets written in Go, and we have a C++ wrapper on top of it. And given C++ is pretty much compatible with Java, Node.js, and Golang, so we have created shared libraries. So what happens is we use NAPI in Node.js, we use JNI in Java to talk to the C++ wrapper. C++ wrapper talks to Go, the Go code, which where all the magic happens, and returns all the results from the query and things like that. So this has really helped us bring down our development time. So basically we write all the complexity in the Go driver, and it gets available in other languages via shared library. So it has made our lives a lot easier, and less error prone also. Just to give you an example, like this is how irrespective of what NoSQL database is underneath, like you get these interfaces, like which are like pretty common functions, for any NoSQL database. Like, so basically, if you want to do batch reads, delete rows, so basically it's a single interface to talk to all of the different databases. So it basically reduces a lot of complexity at our end. And internally, we use the best practices for each of the databases, ScyllaDB being one of them. This has really helped us, do things. So let's now go to the how did we actually migrate data to ScyllaDB without any downtime. So as I mentioned, we basically have a bulk import export job. So what happens is a service integrates with the driver, which has all the details with respect to, this is the table in database A, and this is where we want to migrate to, which table we want to migrate in database in ScyllaDB. So what we do is we make use of timestamp in this case. So what happens is we basically do write with timestamp, because the DB driver is like the central. We write our data with timestamp, and basically there's a bulk import export job. And basically what happens is the last write wins in this case. And so there is very there are no, I would say, overriding of issues because of this. In the next slide we will get to see much more details of it. And because of the driver, it's like this, you can write to two different databases. You can read from one, you can read from your primary database, for example database A. You can when you are confident that what I can read from Scylla, you can say, what, now read from Scylla. Now once you're confident that Scylla reads are performing fine, you can say that, what, I'm good to switch to Scylla. So you can directly now just change the config and say, what, just read and write from Scylla now. So the driver does a good amount of functionality, and all of these are controlled via APIs, and the driver automatically syncs all these parameters. There's also a repair service. For example, now you are doing dual writes, and you see during reads that there is inconsistency of data between database A and ScyllaDB. So there is a repair job. Automatically, this kind of records gets flagged, and there's a repair job which basically takes care of it. So we'll go much more in details into how this happens, how this last write wins helps us. So consider this, like you basically we start dual writes in the beginning. What happens is consider you have a bulk import export export import job. So you, from your database A, you have you get this is a record which has ID 1, first name Geetish, last name Nayak, and company ShareChat. Every column is associated with timestamp T1, right? And basically what happens is, when there's an update that happens via the driver onto ScyllaDB, for for example, update employee set lname is equal to Kumar, where ID is 1. What happens is this we write with the timestamp. So what happens is in ScyllaDB only against ID and lname we have Kumar, which has a timestamp too. And basically when the bulk import export job like tries to insert this data, what happens is because timestamp 2 is greater than timestamp 1, what happens is Kumar does not get overridden, and only the fields that were missing like fname and company have now been written onto ScyllaDB with Geetish and ShareChat. So the last name also gets committed, but because the timestamp on column last name is has a greater timestamp, basically the last writer, the last value always gets read. So that is basically how we have migrated the data. So we make use of the last writer wins concept, and we migrated like this 20 terabytes of the counters cluster all via this. The atomic counters gets handled a bit different way, but the 20 terabytes of data, which was fairly straightforward, and we got like 99.999% accuracy by just migrating this way. And the reason, and all of this was possible because of this centralized driver, which made our lives simpler. And as I said, like we migrated like 20 terabytes of data using this. Yeah. Apart from that, I wanted to discuss about our experience working with managed ScyllaDB. So I think over the period of time, like ShareChat and ScyllaDB engineers, we work like a single team. We consider ScyllaDB engineers to be our extended team, and it's almost like that. Like we have conversations on a daily basis with respect to any sort of doubts, best practices, issues, and they're very happy to give us detailed explanations of why has something happened, and like why is this not a good practice, all of these, and like pointing to the correct documents, explaining us why at a very code level also. So I think that it almost seems to be like a single team, so at least to me, and others also. Our database practices have certainly improved. Like now the thing is there is a shift in how things are working right now. Like we give a lot of importance to our query patterns, our data model. Like I see that the teams are like because of these onboarding documents and all, teams are giving a lot of thought about how will this query work if I have a a larger scale to take care of. I think those things have definitely improved. Again, regular guidance from ScyllaDB engineers has also helped us understand like pros and cons of ScyllaDB features. Like for example, when should you use the user-defined data types, collections, all of those things. What should be the compaction strategy for this kind of use case? So I think we are able to become better which with every use case that gets onboarded, and ScyllaDB team has really helped us in that extent. They have definitely taken a lot of operational overhead from us. So they help us manage the cluster, decommission things, like taking care of upgrades, all of those different kind of problems. Also the thing is like I would say Chatter have also done mistakes, but they are happy, or like they understand that this was a genuine mistake, and they helped us rectify those things. So they have definitely taken the lot of operational overhead from us. Again, like detailed responses to tickets with root cause and mitigation steps. uh, I think the metrics definitely help both like ShareChat and ScyllaDB engineers, because the metrics are so granular. Some of the tickets are really good, like to the extent like what is happening internally, like how is the compaction working, all those things have helped us. Like totally understand that there will be issues. There will always be issues because no product is perfect. But uh, for us as engineers, getting the visibility of why is something happening was something that was missing at our end. And with ScyllaDB, we are able to get answers to those questions. And slow query logs, all of these things has really helped us get to the bottom of the cause, and also the uh, getting the best out of the database that we are using. So yeah, like overall, the experience has been very good between like different engineers within ShareChat and ScyllaDB. Yeah. Uh, yeah. Last but not the least, there were many folks within ShareChat and ScyllaDB both who made all of this successful. I might be the presenter, but there's a big team behind, who has made this successful. So Abhirup was the guy who took the plunge with me to evaluate it. He's a DevOps guy. He set up all the Kubernetes cluster. So Jensen, Chandra, they all kind of helped us to get ScyllaDB onto ShareChat. Like from platform team, these are the folks who very closely work with me. Like the DB driver that I'm talking about, the live migration framework has kind of been very much built and architected by these folks. And then we have early adopters, Ivan, and the bunch of other folks from different teams who really took the plunge. You know what, like we can try out ScyllaDB for our use cases and see how it works. So I really want to thank the early adopters for taking that plunge and trying things out, which has become a lot more successful. Executives also, uh, like you know uh, because this was a pretty huge, I would say, changing databases is not easy, and it was a huge effort from an engineering standpoint. So both the executives from from engineering, data science, have helped us to make it all possible. So yeah, I think that's all I have for this presentation. Thank you.
Wow. Well, I want to thank you and the dozens of people at ShareChat that have just invested so much into the success. And I just think it's remarkable the kinds of things that you've been able to achieve. We have got a number of questions from our users, so you've definitely engaged our audience here. And so I just want to read these to you and get your responses. One of the things that somebody was asking is, what are some of the technical challenges of developing on a database specifically for social media platform? What are the unique challenges there?
Absolutely. So basically, like in a social media app, at a scale where ShareChat is, like the latency numbers are like really really small. Like
Mhm.
almost every service that we use has single digit latency numbers. So the quicker we deliver the request, the better the product metrics are and things like that. So I think the database handling the scale, retrieving the data at much smaller amount of time, handling the scale, all those things are kind of the challenges at least in a social media app.
Right. So the other thing, I think this is really crazy because normally when you want to achieve performance, you throw dollars at instances. But
Yeah,
uh, can you talk more about optimizing for cost and also for performance? Because that was kind of that's a
yeah,
nutty thing for a lot of people.
yeah. Yeah, sure. So basically, like what we have done is, as I mentioned, like we use a lot of best practices, and the thing is, from our nodes right now, we are able to uh, connect from our application nodes. We are able to connect to every vCPU.
Hmm.
So this gives us, you reduce a lot of network hops in between by using gateway and all like that other databases have. You're directly connecting to the node, you're getting your metrics numbers down, your apps are performing really nicely because you don't have to now invest a lot on your CPU cycles and things like that. So it has been like savings at both the end. Like the database is performing nice, the apps are performing nice. You don't require in-memory cache in between. You don't require in-memory cache in your apps. So I think all of these things help actually.
Hmm. So here's another thing. Somebody was talking about aggregating the likes. Now,
Yeah.
are those aggregations being done like in a Flink before you get to ScyllaDB? Are you doing, are you looking to do aggregates within the database? And, talk more about your counter system too.
Absolutely. So what we have is a Kafka cluster, and basically at a very high volume, these data gets ingested, from different services. So once these get ingested to Kafka cluster, we have like good amount of consumers, which does the aggregation. So we use Kafka streams, which does the aggregation like in the consumers. And then there is a, so consider like this, like 100 likes are aggregated together, and the aggregated count goes to counters. So we use atomic counters in ScyllaDB, so that is where the aggregation happens against a particular posts. So there is a aggregation in memory in Kafka, and then there is an atomic counter at the database, and that is how it works basically. And
Hmm.
that is happening across both of our apps, ShareChat and Mods.
So with the distribution of content in social media, you're going to have some hot posts where you could have hundreds of
Yes.
thousands or millions of likes. Do you
Yes.
run into hot shards or partitions when dealing with that?
Yeah, absolutely. We do run into hotshots, and like the metrics. I think one of the metrics diagram that I showed actually, like it actually shows when like one of the vCPU is like very much bombarded. Like it actually shows the hot partitions.
Right.
So that time what we do is like we think of like how many times are we getting these kind of queries? Do we need to further partition our data? So that's a call that we take. And also the live migration framework like helps us, like if you want to migrate from one table in ScyllaDB to another table in ScyllaDB by changing the partition key, you can also do those things. So yeah.
Right. Now, correct me if I'm wrong here. You have 50 million daily users, but there's also time of day patterns too, right? So when do you
Yeah.
see the kind of bulk of transactions occurring?
Yes. Yes. So absolutely correct. Like the morning, early morning, like because it's a very regional. Like we have we support 15 languages. Uh, Early in the morning, there's a huge spike that happens on almost all of our services, and at night time also. So these are like the peaks, and this happens kind of on a almost on a daily basis. So basically, like yeah, like we have tuned, I would not say tuned, but we have made sure that the database has the buffer to take care of these latencies, when there are spikes. We have like retries. Also, again, the beauty of ScyllaDB is like we can change read write consistency, at a query level.
Yes.
So those things also help. Like we have a lot of cases where we do not require strong consistency, and eventual consistency is fine. So we take a call, like do we want to are we fine with eventual consistency, things like that. So yeah, like the spikes happen, but I think we are prepared for those kind of things.
Great. I saw in your slides you had Flink mentioned, you have Kafka mentioned. What other kinds of services are you using on Google Cloud? Describe more some of the systems we're connected to.
Yes. So yeah, the basically like Kafka and Flink is our on in house. So we in Google Cloud we use a lot of Kubernetes. We use cloud storage, PubSub Lite, a lot of their databases, and and like cloud functions. So there are rarely like uh, few services that of Google that we don't use. So ShareChat is a uses Google GCP services to a lot extent, and at a
Mhm.
very high scale also. So yeah, like a lot of services of Google gets used.
Yeah, and then I heard you mention Golang, but somebody was asking here, what other programming languages is ShareChat using? So why don't you describe the programming language
Yeah.
services that you have?
Yeah, so primarily, most of our apps services are in Golang and Node.js. So Node.js has been, some of the legacy services are in Node.js, but primarily right now, most of the services are in Golang. And it has given us good amount of benefits in terms of cost also. And also we use Java, like for example Kafka or Flink and other ecosystems work very well in Java, the events platform and things like that. So those are very much built using Java. So I would say like all the three languages, Golang, Node.js, and Java, are primarily used in ScyllaDB. Like yeah, and I think you can see from the driver also, we had to build the driver, database driver, considering all the three languages in mind.
Mm-hmm. Mm-hmm. So now you've already mentioned that you have like a lot of different clusters of ScyllaDB, each for different particular services.
Yeah.
I imagine you also have a very complex event streaming architecture built on Kafka. So how do you manage topics? How many different topics do you have? And like, what's the kind of rate of events per second that you're talking about?
Yeah. So yeah, absolutely. So we have different Kafka counter clusters because every counter, ShareChat and Moj, as I said, totally two different, I would not say use cases. The use cases are same, but totally different huge scale. So we have two different Kafka clusters for each of the apps, and again, like we have small counter clusters because like it's not just post aggregations, but we have like audio and all those things, the different aggregations that happen. So yeah, basically that is where we have Kafka clusters, and we like the brokers are like 9 node brokers, and they work at I think some 200k 300k messages per second. So yeah, so it's a pretty high scale, and like we have a bunch of I think around 100 200 consumers which do these aggregations and and send it to ScyllaDB. So the scale is like pretty decent, like 200k. It goes to 300k at during peak hours.
So this has just been incredible.
Yeah,
35 Scylla clusters, a million operations per second. I saw on one of your slides there, you're talking not just single digit milliseconds, but your P99s were in microseconds, hundreds of
yeah,
microseconds.
yeah.
This is just an incredible story. We look forward to deepening a relationship with ShareChat over time. I personally wanted to thank you for all of the questions you've answered today. I want to let the audience know that if there's any questions we didn't get to, please make sure that you leave them in the Q&A section, and we will actually take these. We'll talk to Geetish and his team after the event, and we'll write up a blog of all the questions that we didn't get answered today. So on behalf of everybody here at ScyllaDB, thank you again, Geetish, and all your team for your time and your efforts to make this such an incredible story.
Thank you very much, Peter.
All right, and now thank you all for joining us today.